Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 4, structure of the atom. So like if you all remember in part 1 of this lesson, structure of the atom, like we were discussing mostly about, you can say, what exactly is an atom made up of. There were so many things that we have studied in the last part, right? Like I gave you an introductory part to the lesson where I said that we will be studying on different theories given by Dalton, given by J.J. Thomson. Then we have Bohr's theory, Rutherford's theory. Now all of them, some or the other how, they had some of, you can say, like some of the limitations, because of which like they were not able to proceed further, because of which like because of those limitation it got like, you can say ना कि एक chance मिल गया दूसरे scientist को to work on that limitations then. So whatever limitation Rutherford came up to, okay, those limitations were fulfilled and covered by, you can say, Bohr's model. And now today the most accepted model that we have is of Bohr's model itself. Okay, so make sure you all know this in detail. And now I want you all to, because I have discussed it in detail, very detail I guess, so and you have like written a note on it. So now I want each one of you to please go through whatever notes you have taken in the last class, so that we can proceed further with this part 2 where we are going to study the exact lesson. So now you are friends with the lesson already because I have introduced it to you all, right? So now today you will be learning more about it. Okay, so but before starting with it, I want each one of you to please revise it once. I hope everyone is revising it quickly. Everyone please do a quick revision so that we can proceed with the lesson further. You need to revise each and everything that we have studied till now in the lesson. Okay, so after this, like whatever you have like written in your book, after that we have studied that like in chapter 3 we have learned that atoms and molecules are the fundamental building block of matter, right? What are they? They are the fundamental building blocks of matter. So we know that everything around us, like it is made up of, like they're the molecules and the atoms, and that is how they have been built, right? So after that we discussed on that the existence of different kinds of matter is due to different atom constituting them. Okay, so because there are different atoms which have been present over there, they are been responsible for this like formation of a matter. Now you know what is matter? Matter is something that occupies space and it has mass, right? And how is that matter made up of? That matter is made up of atoms, right? So that is why we say that atoms and molecules are the fundamental building blocks of matter, because that is how they have been made. Okay, so now the question is, what makes the atom of one element different from the atom of another element? Okay, this is one of the question. After that, the second question that we have is, are atoms really indivisible as proposed by Dalton, or are there smaller constituents inside the atom? What do you think over here? Like Dalton's atomic theory is also been is also present, right? Like I have already given you some basic information on Dalton, because just imagine, I if I would have started this lesson and if I would have asked you what exactly, like what exactly Dalton has proposed, right? You might have gone blank because you don't know. But now you have already studied a basic, like you can say a point basic points on Dalton, right? So now you have some idea on it. So here what are they asking? Are there smaller constituents, you can say, inside the atom? So we shall find out the answer within the atom itself. Like you will find out the answer in this lesson itself in short. Okay. Okay. So see, we will learn about subatomic particles. Now you even know about subatomic particles, right? What are subatomic particles? Protons, electrons, neutrons, right? These are the subatomic particles. We have already studied about the subatomic particles, like, and we will be studying more in this lesson, okay? And the various models that have been proposed to explain how these particles are arranged within the atom. So we will be studying about the subatomic particles in detail. That is, we will study about protons, neutrons, electrons in detail, and the different models that have been proposed, like by Dalton, by J.J. Thomson, by Bohr's model, by Rutherford. So we will study about all of them, like the models which have been proposed to explain how these particles are arranged within the atom. And along with that, we will be even discussing on a major challenge before the scientists at the end of 19th century was to reveal the structure of atom as well as to explain its important property. Now this was very important for the scientists, because scientists were facing a hell lot of, like you can say, challenges before them till the end of 19th century, and the reason was because like they were not knowing anything about atom. They didn't knew what exactly it is made up of, and there were a lot of confusion that were present. Okay, so like they were along, like by coming up with different model, they were trying to solve that puzzle, like how we solve different puzzles by jotting down all the things together. So these are the different scientists who are working together so that they can find out about it, more about it. Okay, so the elucidation of the structure of atom is based on series of experiments. So now there were many different experiments which were performed, and this elucidation is been based on, you can say, many different experiments and the models that were brought up. Okay, so a major challenge before the scientists at the end of 19th century was to reveal the structure of atom, and that is why they were practicing this so much, to explain the properties, to explain all the properties by performing different experiments. Okay, so one of the first indications that atoms are not divisible comes from studying the static electricity and the conditions under which electricity is conducted by different states. So different substances, this was very important over here, because the first indication that they got that atoms are indivisible, it was been performed because of the you can say concept of static electricity. Now what is static electricity? Remember that experiment where you used to take a comb, rub it on your head, and that is how you used to perform it. So it based on that. Okay, so it was done based on that. After that, the conditions which electricity is conducted by different substances, so this was the major thing which was playing its important role. So here we have information on atoms and molecules, like the figure which has been given over here. I want you all to have a quick look on it. Now if you can see, the atom is having 8 protons, 8 neutrons. Now we know that protons and neutrons, they are present in the nucleus, right? And the electrons keep on revolving around the nucleus of the atom. So this is the oxygen atom that they have given, and the next one is like water molecule, which is represented as H2O. Okay, so it has one oxygen, H2O, it means two hydrogen atoms and one oxygen atom is present over there, right? So H2O and like oxygen, which is having 8 protons, 8 neutrons and 8 electrons present in it. Okay, so I want you all to write like how the first indication of the atoms came into picture. So it was all because of the study of static electricity and the conditions under which this electricity was been conducted. Okay, so I hope everyone is going through it. I hope everyone is going through this slide. After this, now we are going to study about charged particles in matter. So see, atoms have three types of subatomic particles, and these three types of subatomic particles includes electrons, protons and neutrons. Now we know electrons are negatively charged, protons are positively charged, and neutrons are neutral, right? They do not have any charge. So electrons are negatively charged, E minus, protons are positively charged, P plus, and neutrons have no charge on them. So when it comes to mass of an electron, it is 1 by 2000 the mass of a hydrogen atom. And when we consider it, like the mass of a proton is equal to mass of hydrogen atom and is taken as 1 unit. How do we take it as? We take it as 1 unit. So the mass of neutron is equal to mass of hydrogen atom, and we can take that as 1 unit again. Got it? So like they have even shown in the diagram what exactly electrons, protons and neutrons are. So I want you all to please go through this and write some of the parts. Even draw the figure for your proper understanding. Sorry. So as we saw previously that it was all because of like the structure of the atom was discovered because of, you can say, static electricity. So further we are even going to discuss that. So don't worry about it. I hope everyone is writing it, and you need to even like draw the figure representing it, okay? After this, now we have like for for understanding the nature of sorry for understanding the nature of charged particles and matter, let us try out the following activities. See, what we have to do is comb dry hair. Okay, your hair should be dry. You need to comb it. Then you need to check, does the comb attracts the small pieces of paper? Okay, and after that, like that can be seen in the first picture. What we have done, we have like just combed our dried hair, and then we were checking whether it attracts the small piece of paper or not. Okay, then after that, rub a glass rod with a silk cloth and bring the rod near an inflated balloon. Now if you can see what we have to do, we have to rub a glass rod with a silk cloth, and after that, after rubbing it, we need to bring it near an inflated balloon, and after that we need to check what exactly happens over there. We need to observe what happens. Okay, you will see this, there will be a current which is going to get generated, or like you can say uh, for that comb part, you will see that pieces of paper will attract the comb, and here also the glass rod will attract the balloon, right? So from this activity, we can conclude that on rubbing two objects together, they become electrically charged. Like they have asked you, can we conclude that? So yes, we can conclude it that when we rub two different objects together, they become electrically charged. Okay. Now the question is, from where does this charge come from? Because now see what they have stated further. This question can be answered by knowing that an atom is divisible and consists of charged particle. What is an atom? Like an atom is indivisible, and it's like atom is indivisible and is indestructible as well, right? But here what they have stated, atom is divisible and consists of charged particle. So many scientists, they were contributed, like they contributed in revealing the presence of charged particles in an atom, and it was known by 1900 that the atom was indivisible particle. Now if you can see, go back to the first point again, this question can be answered by knowing that an atom is divisible, but it was known by 1900 that atom was indivisible particle and it contained at least one subatomic particle, that is the electron, and this was identified by J.J. Thomson. So J.J. Thomson was the one who identified this subatomic particle called as electron. Okay, and even before electrons were identified, Goldstein in year 1886. Now Electron concept was known by 1900. It was identified by J.J. Thomson. But before the electron concept was discovered, we had E. Goldstein in year 1886. He had discovered the presence of new radiation in a gas discharge and called them as canal ray. So there were some new radiations, okay, which were discovered by E. Goldstein in 1886, and that was discovered, like that radiation of the gas in the gas that was discovered, we know them as canal rays. Now you can get a question on what are canal rays. So you have to know this, that canal rays are positively charged radiation which led to the discovery of another subatomic particle. So these rays were very important because they have given us, uh, you can say they have made us aware about the new radiation in gas, like about a new, you can say, subatomic particle which we know it as protons today. Okay, so this subatomic particle had a charge. These charges were equal in magnitude but opposite in sign to that of the electron. What was it? It was equal in magnitude but opposite in sign to that of electron, and its mass was approximately 2000 times as that of the electron. What was its mass? It was approximately 2000 times as that of the electron. Okay. So it was given the name as proton. So proton was discovered because of the canal rays. Now what are canal rays? Canal rays are positively charged radiation, equal in magnitude but opposite in sign to that of the electron, because we know electrons are negative in charge and protons are positive in charge. Okay, you should be knowing this, that protons are equal in magnitude, opposite in sign to that of electron, and its mass is 2000 times more as compared to them. Okay, then it was given the name as protons, and in journal electron is represented as E minus, E negative should go on top, and protons are represented as E plus. Okay, P plus. So the mass of proton is taken as 1 unit and its charge as plus 1. How do we take the mass of the proton? It is taken as 1 unit and the charge is going to be plus 1. So the mass of an electron is considered to be negligible and its charge is minus 1. So here you know that mass of proton is 1 unit and the charge is plus 1. Whereas you can say in electron it's negligible. Okay, the unit is going to be negligible and the charge will be minus 1. For protons it is plus 1. For electrons it is minus 1. So it seemed that an atom was composed of protons and electrons mutually balancing their charges. What was seen? That electrons and protons, they were balancing their charges. One was minus 1 and one was plus 1, right? So they were mutually balancing their charges, and it also appeared that the protons were in the interior of the atom, whereas electrons could easily be removed off but not protons. So now the big question was, what sort of structure did these particles of the atom form? And we will find the answer to this in the next part that we study. But before we start with that, I want you all to please write, like there are many important points given over here, and it is with respect to like E. Goldstein. Then we have points on J.J. Thomson, which has been given about the discovery of the electrons and protons. Then the mass has also been given. What was the mass? What was the charges that they had, and everything. Like most important questions have been given on screen. So I want you all to please take a note of each and every questions that has been given over here. I hope everyone is writing all the information that has been given on screen. So you need to write each and every point about E. Goldstein, how the discovery of the protons happened, and how the discovery of, you can say, electrons happened, and everything. Okay. I hope everyone is writing this. Now after this we have to study about the structure of an atom. So see, we have learned Dalton's atomic theory in chapter 3, which suggested that atom was indivisible and indestructible, right? We know that atoms are indivisible and indestructible, but the discovery of two fundamental particles, now we just now studied about the discovery of electrons and protons inside the atom, right? So the discovery of this electrons and protons inside the atom has led to the failure of this aspect of the Dalton's atomic theory. Okay, so it was then considered necessary to know how electrons and protons are arranged within an atom. So for explaining this, many scientists they proposed various atomic models. So as I said that everyone was behind coming up with some or the other models, right? So that they can explain how exactly the structure of these atoms are, right? So for explaining this, as many scientists proposed various atomic model, J.J. Thomson became the first one to propose a model for the structure of an atom. Okay, so J.J. Thomson's model was the first model which was being proposed to explain the structure of atoms. So if you can see, the Dalton's atomic theory has been given over here, where if you can see you can say 16 mass unit plus 2 mass unit becomes equal to 18 mass units. Like if I tell you about, if we take the example of, you can say H2O, okay, it also, like, there are two hydrogen atoms and one oxygen atom. So like that way if we consider it, it is going to be the same thing, right? So remember this thing, that J.J. Thomson, he was the first person to propose a model for the structure of an atom. So here whatever information has been given, like the discovery of the two fundamental particles called electrons and protons inside the atom has led to failure of this aspect. Like Dalton's atomic theory failed that atom was indivisible and indestructible, because the theory came up that atoms are, you can say, atoms have particles, subatomic particles called protons and electrons in it. Okay, so I just want each one of you to please go through it once. Okay, I hope everyone wrote from this. Now, because J.J. Thomson was the first one to propose his model, we're going to study the first model as Thomson's model of an atom. Okay, so remember this. Thomson proposed the model of an atom to be similar to that of Christmas puddings. What was he thinking? That the model of an atom can be considered similar to that of the Christmas pudding. So the electrons in the sphere of a positive charge. Okay, the circle that you can see, that is a sphere of positive charge. Inside that we have some electrons which are present. So we like currants, like we have dry fruits added in spherical Christmas pudding, it's like that. And we can even think of, you can say, watermelon, because as I said, like I remember I gave you this example in the last class as well, where I said that the red part is all the, you can say, nucleus, which includes neutrons and protons, and the black seeds which had, like, which is present in the watermelon, that can be considered as the electron, right? Because we know electrons keep on revolving around the nucleus of an atom. So I want each one of you to please just go through this. Okay, and even draw this Thomson's model of an atom. So Thomson's model of an atom was very easy to know and easy to study as well. So I want each one of you to please write about this model once in your book. I hope everyone is drawing this Thomson's model of an atom and you're writing some of the information on it as well. So the best example that you can remember about Thomson's model is, it is like, you can say watermelon. Okay, the black seeds will be considered as electrons and the red part has been considered as the protons and the neutrons, that is the nucleus of an atom. Okay. I hope everyone is like, every one of you have drawn this. Okay, so after this, now we have some information on J.J. Thomson, because as we know that he was the one who had introduced the term electrons, right, as well as the characteristics of electrons. So here we have J.J. Thomson. Now he was born in 1856 and he died in 1940. So J.J. Thomson is a British physicist who was born in Chitham Hill, a suburb of Manchester, on 18th of December 1856. When was he born? 18th of December, like 18th of December 1856, where he was awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electron. So now he was even been awarded with the Nobel Prize in Physics for his work that he had done for introducing the discovery of electron. He was been awarded this Nobel Prize. Okay, so he directed the Cavendish lab at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prize. So he was not the only one who was like doing his work and all. Whoever was there along with him, like 7 of his research assistants, they also like came to a level where they were able to achieve Nobel Prizes for their discoveries. Okay, so now I hope like you are clear with Thomson's model. Now we have some proposals, like Thomson proposed some of the statements which I'm not going to continue today. Okay, so we'll be studying about like what exactly Thomson proposed. Or wait, I'll just complete with it, and then so that we can start with Rutherford's in the next part. So see, Thomson proposed that an atom consists of positively charged sphere and the electrons are embedded in it. What did Thomson propose? That an atom has positively charged particle, like positively charged sphere, and the electrons are embedded in it. The electrons are like the seeds in watermelon have been embedded in it. That is how the electrons are been embedded in it. Okay, so the negative and the positive charges are equal in magnitude. So it means that whatever negative and positive charges are present, because they are equal in magnitude, what happens over there? So because of this, like negative charges and positive charges are equal, the atom as a whole is considered to be electrically neutral. What it is considered to be? The atom as a whole is considered to be electrically neutral. So although Thomson's model explained that atoms are electrically neutral, the results of experiment carried out by other scientists could not be explained by this model. So as we see below, so this is like a you can say Christmas puddings, he said, right? So positively charged are the puddings and the negatively charged are the plums. So this is how he was like trying to make models by himself, and you can see the spherical cloud of positive charges and the electrons which are negative charges which are present inside an atom. So this is the model explained by Thomson. So I want each one of you to please write this propose, like whatever has been proposed by Thomson, please take that in your book, and after that like we will study more about Rutherford in the next class, but please do take a note of this in your book. I hope everyone is writing this Thomson's model. Now after this, in the next class, we will start with Rutherford's model of an atom in detail. Okay, we'll study about them. After that, we will study about like who exactly Rutherford was in detail. Then we will study like why exactly Rutherford's model of an atom failed. So the drawbacks of Rutherford's model as well, we will discuss about it. Then after discussing the drawbacks of Rutherford's model, we will discuss on Bohr's model of atom, what exactly like Bohr's model of an atom is in detail, who was Neil Bohr, everything about them. Then we'll discuss on the energy levels which were been like described by, you can say, Rutherford. We'll discuss that. We will study about neutrons in detail. Okay, what exactly neutrons are. Then after that, we'll discuss on how are electrons distributed in different orbits. So we'll discuss about that in detail. Okay, then we'll discuss about valency in detail, like what exactly valency is, and you should be knowing about valency. Okay, what exactly it is. So we'll study about valency. This is the valency chart that we have. Not only the valency chart, it has the name of the element, the symbol, the atomic number, number of protons, number of neutrons, number of electrons, along with like which are the different like how exactly the electrons are been distributed in K shell, L shell, M and N shell, along with the valency they have been provided over here. Okay, so we'll study about that in detail, what exactly it is. After that, we'll discuss on atomic number. Okay, atomic number and mass number, that is also very important, so we'll discuss about that. And then after discussing about atomic number, we'll discuss about mass number in detail, what exactly mass number is. Then we'll discuss on isotopes, what are isotopes. After that, we'll discuss on the application of isotopes, what exactly the application of isotopes are. Then we'll discuss on what are isobars in detail. Okay, what are isobars in detail. Then we will discuss the summary in detail. Okay, like what exactly we have studied in this whole lesson, structure of an atom, so we'll discuss that in detail as well. And after that, we will be discussing on some of the exercise questions which have been given. So I want each one of you to please go through this exercise question one by one. I hope everyone is going through the exercise question that I'm showing you on screen. I hope everyone is going through this exercise questions. So, like we will be discussing this 19 questions at the end of the lesson structure of an atom, and this is how we will be like ending up with the whole lesson structure of atom. Okay, so I hope whatever we studied today in this part with respect to Thomson's model in detail, and we have like already started the lesson today. So I hope like you have understood whatever we were trying to study and whatever I was trying to teach you, right? So I will be continuing with the further part, that is with Rutherford's experiment, in the next part. But I want you all to please keep on revising everything that you have written in your book, and that is how we will end up the lesson. Okay, so I'll end this part over here, and I'll start with the rest of the part in the next part. Thank you everyone.